I'll get the rest. Hey, Renee. All right, so let's take a second and talk about this. So now everybody got a pretty good start on this, but there was a little bit of confusion with kind of like the order in which you're going to handle the patterns. That's what it is. This will be crystal clear in a second, right? But how are we going to think about this? Because everybody discovered there really were two patterns going on here. We had a pattern that involved a minus and a plus, and then we had a separate pattern that involved a plus, that involved a plus and a plus, right? So we had the pink pattern and the orange pattern. Which one do we have to deal with first? And we have to. No, the pink. How come? Because, so here's kind of what you're conceptually we're battling with a little bit. Do you work from the inside out or the outside in, right? You always work from the outside in. You have to start big and work your way in when you're using these patterns. So when we look at this, first of all, when we look at this thing at the very beginning, we see that I have brackets that enclose parentheses. So the first thing we have to look at are the brackets. If we look at the brackets, what pattern do we have with those brackets? I have an A minus B times an A plus B, don't I, in the brackets? Everybody see that?
I see it.
I've got an A minus B times an A plus B, which is equal to what?
A squared minus B squared.
Okay, that equals A squared minus B squared. Now let's capture what's what. Well, A is going to be 4Q plus 6, right? Is the quantity 4Q plus 6. B is just P, right? So the first step would be I end up with A, which is 4Q plus 6 quantity squared, minus B, which is just P squared. Okay. That one's easy. P squared is P squared. Done. This one's a little tougher. Which pattern is that one following?
A plus B squared.
Yeah, right. Now that's following the pattern A plus B squared. So now we got a new A and B inside of the original one, right? Now we've got A being 4Q and B being 6, right? Okay, well, what is that pattern? What is A plus B quantity squared going to give us?
A squared plus 2AB.
A squared plus 2AB plus B squared. That's what this whole thing gives us, right? We can replace the A plus B quantity squared with an A squared plus 2AB plus B squared, right? Okay, so now we can replace our versions of A and B. Whatever we have for A is going in there and there. Whatever we have for B is going there and there, right? Okay, well, what's A? B is 6, right? So now we can simplify that. What is 4Q quantity squared?
16 squared.
16Q squared. 2 times 4Q times 6 is 2 times 4Q times 6 is 48Q. And then 6 squared is 36. So now we've got all that stuff, right? And that's it. Everybody see that? See the organization though? We first had a conjugate pattern. Once we apply the conjugate pattern, Then in the process of simplifying that, well, we had a binomial squared. Okay, make sense? All right. Okay, so now we're going to add one more piece to this. So you guys in the honors class, we get the cubic patterns also. So the cubic patterns, a plus b quantity cubed, and you just have to kind of memorize these. There's a couple easy ways to do this though. What you notice here, when you're trying to memorize this pattern, notice that I get 4 terms in each of these expansions. Notice that the sum of the exponents is always equal to whatever the power of the binomial is. So I've got an a cubed in the first term. Second term, I've got an a squared times a b to the 1. 2 plus 1 is 3. Third term, I've got an a to the 1 times a b squared. And then finally, I get a b cubed. So the exponents always add to 3. The coefficients of the middle 2 terms are also equal to whatever that power is. So they're both 3's. And notice what happens to the exponents. They start, all of the exponent is given to the a, b gets nothing. Every term, the a is going to get reduced by 1 and the b is increased by 1 until eventually the b gets all the power in the last term, right? Okay, if it's an a plus b quantity cubed, all the signs are plus. If it's an a minus b quantity cubed, it just starts positive and alternates. Okay, and then you get both patterns pretty easily. Once you see those sub patterns, the patterns within the pattern, it's pretty easy to just write down those 2 expansions. Okay, everybody try it once without looking. Can you tell me what a minus b? Everybody try this on your scratch paper. Well, you don't have scratch paper. Just tell me up here. A minus b quantity cubed is what? A cubed.
Minus a squared plus
3a squared b, good. Plus
a
3
b squared
minus b cubed. And the other thing you notice is the exponents are symmetrical, or the coefficients are symmetrical, right? It goes 1, 3, 3, 1, right? So if I split it down the middle, they're like symmetrical versions of the coefficient pattern. Okay. All right. So then we could easily apply the a plus b cubed pattern to this, right? What am I going to get if I apply this one?
x cubed
plus
I said x cubed, okay?
plus 3 times. Well, we'll do it in steps. 3 times x squared times 7 to the 1, good, plus 3 times
X times
7 squared, good, plus 7 cubed, good. And if we just simplify each of those terms, that's x cubed. What do I get here?
3x squared 7.
Okay, now it gets a little trickier because I've got 49 times 3. What's that?
147.
147, yeah. How can you do that quickly? You like my snapping? What would 50 times 3 be? 150. So 3 times 49 would have to be 3 less than that, right? Okay. 7 cubed?
343.
Yeah. Yeah, that's good. Okay? Good. Make sense? Okay. So what about something like that?
Wow.
Same thing. Which pattern we're using? Top or bottom pattern? Bottom. Okay, so we're using this pattern where A is what?
6x.
6x. Good. B is 5. All right. So if we apply the pattern, we're going to get A cubed, which is 6x quantity cubed minus 3 times 6x quantity squared times 5, and there's that plus 3 times 5 squared, good. And there's that part. And then finally, minus, good. Okay, and if we simplify that whole thing, what's first one going to be? I got to cube the 6.
So 216x.
Okay. 216x cubed, good. And then what about here? Now this part, the 6x quantity squared is going to become
36x.
okay. So it might be easier then, like to do probably to do the, what would you do first there? Well, it didn't matter. Like if we did 3, we got a minus. 3 times 36 is what? 108 times 5 is pretty easy, right? 540. X squared. Here, this turns into a 25, right? 25 times 6 is easy. What's that?
30.
150 times 3? 450. And then 5 cubed? 625. Okay, makes sense? Good, good. Okay, so last issue then is what happens if we are evaluating functions at algebraic expressions. Okay, that's no big deal. We follow the very same rules that we follow when we evaluate functions at numerical values. What do we do if we evaluate a function at a number? Don't we just plug that number in for the variable? And what was our rule? We always want to put parentheses where the variable used to be, an empty quantity where we dump the number in. Same exact thing's going on here. Wherever I used to have an x, I'm going to replace it with only the quantity a plus 3, right? So that's going to look like 2 times the quantity a plus 3 squared plus 3 times the quantity a plus 3 minus 4. Okay, so what would I have to do first when I'm simplifying this then? By PEMDAS order of operations, what's first? I got to square out the a plus 3. So what's that going to be? A squared plus, close, 6, right? 2ab. So I'm going to get a squared plus 2 times a times 3, right? So there's going to be my 6a plus 9, right? And that, what expansion is that? That's just the a plus b quantity squared expansion, right? Plus, if I distribute the 3 while we're at it, I just get 3a plus 9 minus 4, right? Now I would just distribute the 2. And then 9 minus 4, we'll do all the adding like terms at the end. And then last step is just combine like terms, right? Make sense? Okay? Stop. Make sense? Good start? Okay, I'll put the assignment up. You can jump into it, start working.